Okay, so the first question that we're going to focus on, right, is the one that is talking about a situation where a car that costs X rands is going to experience a couple of things. So let's read through the question together. A car costs X rands, right? The value of the car decreased by R% annually on the reducing balance method. After 42 months, the book value of the car is half of what it was worth when it was bought. Calculate R. Okay, cool. Now, what we are going to do is just try and highlight the key important features of this beautiful love letter that we have here. This question is about depreciation on something called reducing balance method. So those words, these kinds of words like reducing balance should actually mean a lot to you as a mathematician, right? So these are the questions that I call pain questions. This is a pain question, a typical pain question, which is going to be about a depreciation of an asset. In this case, it could be or it could not be an asset. There's a lot of debate about what makes an asset and what doesn't make an asset, but that is another story for another day, right? So what I'm going to try and do is feed all these variables the information from the given statement. The first part says a car costs X rands. Now you'll agree with me that that X rands you see here, this is the original price of this particular item, which means that is the principal value of your car. So which means for P, I'll put the variable X. The value of the car decreases, right? So this is an important word. We will look at it a bit when we start writing our formulae. By R% annually, right? So which means my interest is going to be R%, that's R over 100. They said annually, which means that is every year on reducing balance method. Now the formula that we use for reducing balance method is A equals to P into 1 minus interest to the power of the exponent n. If they said straight line method, then you would use the one of 1 minus I times n. But this one is going to be exponential because they said reducing balance method, right? After 42 months, they said 42 months. Okay, this is 42 months. After 42 months, that's the period it took. The value of the car, the book value of the car is half of what it was, which means it's going to be half of the original cost. And we know that the original value of the car was X. That means our A value will just be half X. Right. And then now we are required to work out the value of R, which means the unknown is there by I. If you look closely, you'll see that we're actually interested in finding what is the value of that R, the rate of depreciation that this car was going through. All right. Now, there's different ways that you could actually work with this question. Some people, right, prefer to substitute the information from the story into the formula and then simplify. Some people prefer to make the unknown the subject of the formula and then substitute once and then press the calculator once and then get an answer from that. So we'll try both methods. But for this example, I'll just take the stuff we've just found and substitute in the formula and try to make the unknown the subject of the formula. Let's just see how that is going to work out. According to this, our A value is half X. So I'm going to substitute half X equals to, your P value is equal to X, 1 minus. The interest was given to us as R divided by 100. Now the N is in months, but the rate is in years. So we need to convert that 42 months to years. And the way of doing that, how do you convert months to years? Well, go to your calculator and then press the number of months that you have and divide them by 12 because in a year, there are 12 months. Then you'll get exactly 3.5, which if you press the change button, it just changes between the mixed fraction, proper and improper fraction. I like 3.5, so I'm going to take 3.5 as the number of years that we are working with here. So this is 42 months, but it's 3.5 years, right? So for my exponent here, I'm certainly going to sit with 3.5. Now from here, the rest is just a basic algebra, making R the subject of the formula. Don't let that X intimidate you because when you divide both sides by X, the X is simply going to fall off, right? So this X will cancel that X out. You're left with only half on your left, so which means half is 1 minus R all over 100 to the power of 3.5. Now I'm after the stuff inside the brackets. So in order for me to get through those brackets, I need to deal with the exponent first. So we are going to introduce a root that matches the exponent. So 3.5, what you do on one side, mathematically you need to repeat on the other side, right? So that root will kill the exponent 3.5 that I'm looking at. I'm now sitting with 1 minus r over 100. This is going to remain 3.5th root of 1 over 2. You're dealing with very smart calculators. They will know how to handle that, right? And then I want to make r the subject, so I'm just going to do what I call sim swap. Take this one to the side and take the r over 100 to the left. So I'll be left with r over 100 is 1 minus 3.5th root of 1 over 2. Right. Then obviously I'm going to just have to multiply that. My r will just be 100 if I multiply both sides by 100 times 1 minus the root of 1 over 2. This is basically what you're going to end up with. And then you go to your calculator, you try and punch all that stuff in this calculator. These calculators are smart. They'll be able to assist you to get that. So I'm going to press 100, and then I'm going to open a bracket here. I have got 1, and then it says minus. Now I need to create a root. So I'm going to press, first of all, that button that is written second function, and then I'll push that one with a root there. You'll see it creates a box for you to put 3.5. And then if you go inside with the arrow, you again put a fraction here and then put 1 all over 2. So I just succeeded to have that. I don't need to close the bracket, but I can just be nice and close the bracket, not inside, backspace. Let's go a bit more further. And then you close the bracket, you'll see this is exactly what you want to type. And then you press your calculator, it gives you 17.97. So the rate of depreciation is 17.97% per annum or annually. So that's actually what you would need to do if you had to work out the interest under these circumstances. Right.